Right now we're going to talk about the electrical system. This house, as I mentioned, is off-grid, and we are powered by a micro hydro electric system and solar PV panels. We have about 5.5 kilowatts of solar PV on poles sitting out in the backyard, and a micro hydro system that generates about a kilowatt of continuous power 24/7, as long as the water is flowing in a small stream just outside the house here. Those two electrical production systems generate DC power that is charging up some batteries that we have here through a series of charge controllers. That DC power that's stored in the batteries here is then converted to AC power through a series of inverters. And what we have hanging on the wall here is all the wiring to power the DC batteries and the inverters. We have circuit breakers to control on the AC side. All the inverters are fused, and all the DC side over here with circuit breakers as well, both to control the input and the output to the inverters. I have a full monitoring system here where we can look at all aspects of the AC and DC, see what the sources are producing for power at any given moment. There's also a history of power that's produced on a given day, month, or year. And we can look and see the state of the batteries, what percent charge they're at, are they charging or discharging at the moment. We have a master inverter that's working 99% of the time, and as more and more current is being used to power appliances and utilities, additional inverters will kick in as needed. So it's a very efficient system. We have 17.4 kilowatts of inverters, very large system. Probably the average home would only need 2 of these inverters. We've got 4 scheduled to go in, a 4th one to go in very shortly here, primarily because we're running a geothermal heat pump that requires a lot of electricity.